And that being said, we are going to move on to our next speaker. All right, we are on time. We've got a lot of stuff today. Tim, thank you so much. That was fantastic.
Thanks, Bart.
Our next speaker is Eric, who is our very first, very proud to say, our very first Data on Kubernetes ambassador. Tim, you could be the second. Anyway, Eric is an awesome participant, an awesome community member who's giving tons of talks and workshops now about some of the things he's going to be mentioning today. Eric, we actually have him signed up to give 2 talks. So we'll have one right now and then one later on in the afternoon with Alex from DataStax. Anyway, Eric, great to have you with us. You can jump right into your talk.
Awesome. Well, I will try to kind of monitor YouTube chat on the side here while we're going. Just got to say, man, Tim really kind of killed me on style for the PowerPoint there. I don't have little stick figures.
But it's amazing. Elegant stick figures. No, it'll be good. It'll be good.
Yeah. All right. Let me go ahead and share my screen. Hopefully
Perfect.
It's coming through. All right. So, hi, everyone. My name is Eric Zietlow. I'm a few different things, but as Bart mentioned, I am an ambassador for the Data on Kubernetes community. So basically what that means is I get to take credit for all of Bart's work when I'm talking to people, which is pretty fantastic because he gets way more done than I do in the day. So I'm also the director of developer advocacy at MyData. I've done a lot of open source stuff over the years, contributed to projects. I've done some commits to various projects, you know, just various things. I'm an open source for life kind of person. I've also been a distributed systems solutions architect back with Cassandra. I actually used to work at DataStax prior to MyData, so did that for a number of years. Been a network engineer, software engineer, kind of run the gambit, as it were. So, all right, real quick, before we kind of get into the technology side of things, I just wanted to talk about why it's important. CNCF did a survey last year where they basically asked people, are you running stateful containers in production? Are you running containers? How are you doing them? They had a whole list of questions. And actually, I believe Bart in some of the newsletters has cited these exact stats a few times. I always talk about them as well because they're important. Containers as a technology are here to stay. They've gone up in 4 years, gone up 300% in usage. So what originally, I remember about four and a half years ago, I was talking with a coworker about containers, and we were kind of discussing, well, is it a fad? Are they really going to overtake VMs? Are they here to stay? At this point, we can say yes, containers have won. They're here, and we actually have to figure out how they fit into the ecosystem in a broader context. And honestly, in many ways, containers are actually taking over the entire ecosystem. People are actually starting to run 100% of their infrastructure in a containerized way, which is really, really cool, but also really scary when you realize what containers are and how they're ephemeral. And natively, they're not actually built to do some of these things that we do in the Data on Kubernetes community, the things we tend to focus on. So some interesting things have arisen from that, and we'll get into that in a moment here. 55% of the respondents to that same survey actually said they were using stateful applications in containers in production. So what that means is whether it's Kubernetes, whether it's some other containerization technology, they were actually running stateful workloads, so things that actually need to save data somewhere or save the state of an application. They're running those inside of containers. So either they're using a solution that already exists, or there are a lot of home-baked kind of cobbled together solutions out there that people just were running in production. And that's actually why MyData as a company exists, is to solve this particular problem. Okay, so when you have a stateful workload in a container, there's basically 2 things. In Kubernetes, there's 2 things you need. First, you need a stateful set. A stateful set is a way that you can basically persist a pod beyond what your normal pod would live for. So what that means is when you have your pod and you set up a stateful set, that pod becomes unique. It gains a basically life, an identifier of its own. And when you do something to that pod, that changes that pod permanently. You're not in this ephemeral world where you can just nuke that pod, spin up another instance of it, and voila, it's back to its fresh vanilla state. You're in a space where that pod is now kind of like a living thing that's going to persist past that. So if I reschedule it, anything like that, it's actually going to maintain a lot of the attributes. Now, the second piece of this is the storage. You actually need somewhere to put that data that's not going to go away. And in stateful sets, you can do some stuff with like local path. You can do, there's a lot of different storage technologies out there that have different storage classes. And to be quite frank, there are probably, I can think of actually a couple extra that aren't even on the slide just off the top of my head. There are a lot of technologies, but a lot of what it boils down to is what is going to be correct for Kubernetes. Now, I saw in the chat earlier in the previous talk, someone was mentioning Longhorn and OpenEBS and kind of the shared roots that they have. And it's very true. OpenEBS and Longhorn actually basically come from the same project. They're early fork of the same thing. There's also Ceph, Storage OS, Gluster, few other things out there that are very, very usable to help solve this problem. Now, I'm going to talk about OpenEBS today because I work with it mainly in my day job. Of course, at Maya Data, we're one of the main contributors to that project. So OpenEBS really is going to be most of what I talk about here today. But just understand there are options out there beyond OpenEBS. Definitely go in anytime you are looking at a technology, trying to fulfill a technology concern like this. Vet technologies, test things side by side. I'm not just going to tell you to go to OpenEBS. Check out Longhorn, check out the other things that are in this ecosystem that work natively, and then make the best decision for you. So just throw that out there. Okay, so what is OpenEBS? Quite simply, it is the open source version of Elastic Block Storage. Now, you probably all, if anyone here has worked with AWS, you've heard of AWS EBS volumes. This is basically exactly the same thing, but the open source implementation of it. An EBS volume is just an elastic, meaning it's sizable, you can actually manage it. Block storage is a certain kind of storage. It's different than like a document store or kind of anything else. It's basically the same as it's trying to mimic a drive. For example, a actual spinning hard disk is essentially a block storage device. The elastic nature of it means we're kind of virtualizing a component of that, but the block devices themselves are being utilized, in my opinion, correctly underneath for good performance. So that's essentially what OpenEBS is at its core fundamental technology. Now, there's actually a lot of really cool backend things that you can kind of glom onto with OpenEBS, some stuff like NVMe over Fabric and some other really, really, really cool things. But fundamentally, the OpenEBS layer is just creating this elastic block storage layer between your actual physical devices or your maybe kind of SAN setup and your actual pods themselves. Okay, so in container attached storage, I'm going to use the word container attached storage a lot. I wanted to define it, or CAS is how I might refer to it. I wanted to define it here because it's kind of important. Container attached storage is basically storage that is essentially co-located with the thing that's consuming it. So when we have container attached storage in a Kubernetes cluster, I want that storage to be living essentially in that cluster itself so that my pods can consume it efficiently and correctly. Okay, so simple Kubernetes, what does it look like? Has a master, has workers, right? Everyone knows this here probably, you're at KubeCon. What we get into are the different parts of the master and the workers here. So the API server, of course, is how we as operators interact with our clusters. So when we're actually in there typing, kubectl command, boom, and firing that off, that hits the API server. The controller manager and the scheduler basically handle how those commands get executed. So where they're happening, when they're happening, all of those components of the system are basically being controlled by controller manager and scheduler. Then we have etcd. Now etcd we're actually going to utilize, or I should say OpenEBS is going to utilize as well. etcd is basically your phone book. It's the store of all the different pieces of technology working together. When I want to reference something from, say, one pod, I'm going to reference it by a service name or some sort of identifier, some tag maybe. That's all stored in etcd. It's basically the lookup. It's where I can say, hey, I need to get this network service. What is the actual connection info for that service? So like physical IP addresses, ports, things like that. Those are all basically mapped in etcd so that they're just service names or tagged resources, which are really, really, really powerful. And it's actually one of the cool things about Kubernetes, because now I can set up these giant architectures and reference everything by a service. So really, really powerful there. All right, the worker has a couple things. It has the kubelet, which is essentially the Kubernetes process that's running on that worker node, that computer, that physical box or VM or whatever it is, depending on if we're running in the cloud. We have cAdvisor, which keeps track of the local resources for that worker. Then we have kubeproxy, which basically handles our networking. So all this communication that has to go on between different workers, between pods, between the outside world, that's all going through kubeproxy. It takes care of kind of the entire job of networking, which is actually what my degree is in, is made somewhat obsolete by kubeproxy, which is very, very cool. So, and then we got our pods. Now pods, it's important to note, are ephemeral, and we can have many of them per worker, and we have many, many of them in our Kubernetes cluster. But like I was saying before, if we don't have statefulness to these pods, when I say want to scale something up, I just add more pods based on a template, and that template is just a YAML file generally, and I just go ahead and apply a YAML, increase the number of pods, and basically end up with multiple copies of the same thing running side by side. And in most cases, if I were running, say, like a front end of maybe a web app or something, that's awesome. I'm good to go. I don't really need that to persist any data. When we start getting into stateful sets, that's how we're actually creating a persisting pod. So a pod with a persistent identifier. Okay, so putting it all together, this is your simplest, well, pretty much your simplest Kubernetes setup. We have our master, we have our workers. You could have kind of a master control plane if you wanted to, and if you're getting more expansive, and we could have many, many, many workers here. These pods can get just massive, and it gets a little more complex as we do that. But this is pretty much the simplest you get. Now, when we actually want to communicate, obviously I brought up kubeproxy with the outside world. The outside world is traditionally what we would use to essentially store data. So databases as a service, or maybe we would co-locate with our Kubernetes cluster some sort of a database, NoSQL database, SQL database, whatever. We would co-locate that and actually just utilize a driver to communicate external to our Kubernetes cluster. So we're not actually storing any data inside of Kubernetes because, again, everything's ephemeral. We don't want to do it that way because we could risk losing data if we had anything go down. Our data would disappear. So database as a service was huge. S3 buckets, referencing them as an actual data store is a very huge thing. We're not doing that though. We're actually going to take that and we're going to erase all of that outside world data store stuff. We're going to try to do it all inside of Kubernetes. Now, that's where the stateful set comes in. So we basically wrap our pods in stateful sets and give them uniqueness. Now, every single pod we have doesn't need to be in a stateful set, but everything that's running a stateful workload should have that associated stateful set. That's basically giving it, again, this persistence. So we're not going to actually lose our pod. If I was running, say, like a MySQL database, I wouldn't lose all of my database specific things from that one specific pod if that pod were to go down, including stuff like, for example, a mapping to a particular storage. I could actually just bring that pod back up and it would bring up that same pod with the correct mappings and everything already running. So, okay. So then we have our persistent volume claims. Persistent volume claims are actually used by pods to basically utilize storage. So our persistent volumes could be anything. It could be a SAN, it could be some giant storage thing. For example, like MayaStore, which is a component in OpenEBS that does some really cool like NVMe over Fabric. So it's basically like iSCSI, but using NVMe protocol, so really, really fast. We don't really care what that persistent volume is. It could be a spinning platter disk or an SSD drive. It doesn't matter to us. We just are going to consume that using a persistent volume claim. And that's a Kubernetes way of doing things. Now, in order to get something that is consumable by a persistent volume claim, we're going to need OpenEBS. So OpenEBS essentially sits between our application, our stateful workloads, and the actual storage system, and it handles all that wiring up of things for us. So more or less, when we actually take the application and we're, instead of using a direct path to storage, we're actually handling all of our storage resources like EBS volumes. They're actually block devices that sit in a block device pool, and then we consume them as we need them. So pretty powerful, really, really good for not needing to kind of wire up everything manually, which can get really, really complex. Okay, so what does this look like? We actually add in the OpenEBS control plane, which has a couple different components, and that's going to actually go through and do all the wiring for us. So on the master side of things, this is co-located on the master. We have the node disk manager operator. We have the Maya API server, which is really, really interesting. We'll get into that in a moment, and the local PV provisioner. Now, the Maya API server sits on the actual, basically it extends the Kubernetes API server. And
Eric, sorry, really quickly. Can you stop sharing and then start sharing again? Because there's a little bit of a lag with the slides.
Yep.
No, it's not frozen. There's just a little bit of a lag. Yeah.
No worries. Let me.
Thanks to the folks who mentioned that in our chat. Let's see if he just pops back out, pops back in. We should be good to go.
Yep. Trying to go ahead and just do stop share. And screen share, boom. All right, hopefully that updated for everyone.
Let's see.
Let me know if we're good, and I will keep on going.
Yeah, no, I'm still not seeing, not yet. Oh, yeah. Okay, looks like it's better now.
Cool. All right, awesome. Yeah, so my API server just extends the existing Kubernetes API server. So basically, when I run my commands, I'm running everything as kubectl commands, basically in a Kubernetes native way. My slides aren't switching over now. Give me one moment. All right, there we go. Local PV provisioner creates the actual persistent volumes. So those volumes that we're going to use the PVC to actually glom onto are being created with the local PV provisioner. Now, those are created in a block device pool that's maintained by NDM. And we'll get into that in just a moment. Because Node Disk Manager actually is a daemon set that basically lives on these individual worker nodes. It's kind of attached onto the kubelet, essentially. What it does is it just basically scans for resources on those particular worker nodes, and it says, okay, I'm supposed to look for these kinds of devices on the node. Here I see like 3 of them. I'm going to put those in the pool, and I'm going to register those in etcd. Remember I said we're using etcd for this. I'm going to register those in etcd as valid block devices. So they're now part of the pool, and it allows you to tag those devices and then consume them as an actual device for your setup here. So what does this actually look like then? We have NDM, which creates the pool. We have the local PV provisioner, which then takes those devices from that pool and links them up so that our PVC, our persistent volume claim, can consume that device or allow a pod to consume that device more accurately. So we can have a pod that has its own storage, and since it's got a stateful set, that storage, we're basically binding it to that particular piece of storage, and we're not going to lose it. So if I were to spin up another instance from that same template, instead of a deployment, I would get a new block device being consumed from that pool and a new unique pod that's created. I wouldn't get like the deployment ephemeral where it's all just copies of it, copy, 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 I would get an actual another instance. So if I was running like MySQL, I'd be running 2 instances of MySQL that are running side by side and storing in different locations. So pretty cool when you actually get down to it, the stuff you can do with this. And this is actually Kubernetes native in many ways, I like to say, because everything I'm doing, I use kubectl commands to do. I'm doing it all inside Kubernetes, and I'm using Kubernetes correctly while doing it. Looks like I'm almost at a time here, so I am going to go ahead. If you want to check out the project, highly recommend you do. It's open source. OpenEBS is obviously open source. It is CNCF sandbox project as well. I have some links here, the GitHub, the website. There's a Slack, Twitter, and everything. So yeah, are there any questions?
I think we got a couple of minutes.
Okay,
so
perfect.
you know, Eric, you know, coming from someone, you know, who was working in data stacks, now moving over to a more specific niche, and also now as someone who's, you know, giving workshops, what are some of the questions that you frequently get from folks that are starting to use OpenEBS?
Yeah, why? Why is probably the number one. And you know, that it's kind of funny to me because when you sit down there and you look at Kubernetes and you say, okay, well, I can actually create something with, you know, local devices where I'm typing in my own, I'm essentially creating my own paths to my storage, right? I've got my storage class. I'm literally just referencing a local path to a device and doing that all myself. And you start looking at that, it starts to be kind of a question that seems valid at first until you realize just what a spider web you can create. You add any complexity at all, and suddenly you're now trying to manage basically these containers, the storage for these containers, how it's all wired up, whereas OpenEBS basically does it for you in a very efficient way. It's actually creating EBS volumes. So they're attachable, they're detachable, they are persistent, you can recycle them, you can do all these things that you just don't have the easy access to do. And the cool thing is you can do it while everything's live. So it's essentially hot swappable, because I can take a pod where, you know, normally I would basically do a rescheduling of that pod to, you know, take so I have a stateful set, I have to reschedule that pod, and you know, that piece of storage would basically be a local path thing that I would need to change. Or I could just go to OpenEBS and have it you know, connect or disconnect that particular block device storage kind of for me. It's actually a much cleaner way to do things. So
Okay, and we got time for one more question. And does it support sync replication or async replication?
Ooh, that's a good one. So what I covered here was the simple local PV version of OpenEBS. I mentioned this kind of in passing in my talk, but there is more than local PV that we can glom onto. So the Maya store that I referenced is actually it supports all sorts of replication. Or I should say it's in development right now. So some of the replication is there, some of it's on the way, but yeah, it's basically would allow you to replicate across like AZs. If you're maybe running in like AWS or your GCP, you could actually replicate across different availability zones or do a whole bunch of really cool stuff with data replication. Yeah, absolutely.
Okay, good. Perfect. Thank you very much, Eric. We're right on time. So now we're going to move on to our next talk. We will see Eric later today with Alex from DataStax to give another talk.
Yes.
So Eric, take a break, relax, and we'll see you soon.
Sounds good. Catch you then.
All right. Peace. So our next